Question 5. Two cars, A and B, moving in the same direction along a straight horizontal road. Car A moving with uniform acceleration 0.4, car B moving with uniform acceleration 0.5. Uniform means constant, so that makes me think of the constant acceleration formulae. At the instant when B is 200 meters behind A, the speed of A is 35 and the speed of B is 44. Find the speed of B when it overtakes A. So I'll just draw a diagram for this. If I start with the fact that B is 200 meters behind A, so I'll mark A here and I'll mark B here, and they're both travelling along this straight road. So at this point t equals 0, B is 200 meters behind A. Now if we're finding the speed when B overtakes A, that means that at some point B and A, when they're travelling along this road, they reach the same point at the same time. So let's call that point P here. So A travels to there and B travels to there. Let's call the distance that A travels x, because we don't know that, and obviously that's x as well. So imagine they set off at time equals 0 and they're travelling at different speeds but at the same time, so t is equal for each of them. They've reached the point P. Now they haven't travelled the same distance, they've just travelled for the same amount of time. So I'm going to make the suvat equations for both of them. So S, U, V, A, T. For A and for B. So the distance travelled in this time for A is x, and the distance travelled by B is x plus 200. The initial velocity of A is 35, so this is the instant when they start off, 35, and the speed of B is 44. They are accelerating, so that's the initial velocity, but that's not the final velocity. So the acceleration of A is 0.4, A is 0.4, and for B is 0.5. And they have reached their destination P at the same point so that B can overtake A. We don't know what the velocity is for A, but we don't care. Do need to find the velocity for B. So I can't, I've got x as an unknown, v as an unknown, and t as an unknown there. I've got x, v, and t as an unknown there. So I'm going to need to do some kind of simultaneous equations or equating. I'm going to use the one without v for now, so that I can make an equation just in two variables, x and t. So for A, so if I haven't got v, I've got s, u, a, and t, so I'm going to use s equals ut plus a half at squared for both of them. So for A, we've got x equals ut plus a half at squared there, and I'll just neaten that up a little bit. X equals 35t plus 0.2t squared. For B, B has travelled x plus 200, so S is x plus 200, U 44, T plus a half A T squared. I'm always wary about doing any calculating at this point, because you get the marks for showing, you get accuracy marks for showing a completely correct equation. So now just neatening this one up and putting it equal to x, because then I can see that I can equate the two. So I'm going to subtract 200 from both sides. 44t a half of 0.5 is 0.25 t squared, and subtract 200. So now I can equate a and b to eliminate x and find a value for t. I wouldn't be able to do it the other way around because I've got t there and I've got t squared, so I wouldn't be able to eliminate t. Okay, so I'm just going to make an equation for equating these two here. So I'll put this on the left. 44t plus 0.25t squared minus 200 is equal to 35t plus 0.2t squared. And now I'm going to subtract 0.2t squared from both sides. So 0.05t squared, subtract 35t, so plus 9t minus 200 equals 0. And you can either factorize that. It does factorize. You probably want to do a little bit of fiddling around beforehand. So you've got t minus 20 and t plus 200, or use your calculator to solve it. So t equals 20, because if we have t equals negative 200, that's basically before the time of the journey. So now that I've got t equals 20, if we look back at what we've got for b here, if I know t, then I've got 4 things involved in an equation. I don't need to use my x. So I've got u, v, a and t. So using v equals u plus a t, I'm going to say that v is equal to 44 plus 0.5, and now I know time is 20, so that's equal to 54 meters per second. So marks wise on this, there's a mark for seeing that s equals ut plus half at squared has been used either here or here. So one method mark for showing it in either of those. An accuracy mark for a correct equation in x, so either this one or this one, A1. And an accuracy mark for a correct equation in x for this one, for B. Then a method mark for an equation only in t, so having eliminated x. Then an accuracy mark for a fully correct equation. So this one could have errors in it, but you've attempted to make an equation in t. You've got the method mark fully correct and all on one side like this, accuracy mark. And then a method mark for solving, either you've factorized or you've put it into your calculator, and an accuracy mark. So you can still get this method mark. Then even if you use your calculator, then using v equals u plus at, a method mark, that's a dependent method mark. Now you can only have that depending on showing you're working out to find the 20. So if you haven't earned this method mark here, or this method mark here, sorry, to work out the 20, you can't have this method mark. And then an accuracy mark for the final answer, correct.